Please join me in giving a warm welcome to the stage to Parth.
So, hi everyone, my name is Parth, and yes, as Andrew said, this is my first time presenting at Datadog-Con conference. So today we are going to discuss about the dark side of GraphQL and what are the attackers' perspective to GraphQL. Let's get started. So here is my intro slide. Hi, I'm Parth. I'm a community leader at Bug Access, security analyst intern at Cequence Security, and I guess there is some issue with the rendering of this stuff. That's why it's not formatted, but that's fine. I'm an avid reader. I like to read money books like Psychology of Money, Rich Dad Poor Dad, etc. And also I do some bad jokes, so we'll have a couple of them in the presentation. Yeah, that's pretty much about me. Let's start. What is Cequence, or about Cequence security? So we are an API security company. We do three major things: discover, comply, and protect. So we have a line of product which can automatically discover your APIs and protect them and find issues in them. And we are also a customer of Datadog. We use them heavily. So without any further delay, let's get started with GraphQL and the attacks. So what is GraphQL? GraphQL was developed by Facebook, now known as Meta, as the query language, and it has three major benefits. That is increased efficiency, better flexibility, and it facilitates collaboration. So increased efficiency is the major thing, and we'll be discussing that and also how to exploit that in a while. So why do we want GraphQL, or why settle for simplicity of the rest? The kind of bad joke again. So when you can spend time writing complex GraphQL schema that nobody understands. So writing a GraphQL, or if you have worked with GraphQL, it's very tough to write query calling up an edge or a node, then querying a data. In REST, we have simple post, delete, put, everything to update. Here we have mutations. So then you have to perform or give out the variables, call out different queries, edges, and nodes just to change a single data. So how GraphQL is different from REST? Here you can see that, let us take an example that there are three calls to be made, that is teams, players, and matches. And in REST API, for getting data of those three endpoints, we need to make three transactions. That is, first you go to teams, then you are like, oh, what players are playing? So you'll go to the players, then you will go to the, okay, now if this player is playing in this match or not. So then you will go to the /matches. When it comes to GraphQL, it's literally simple. Those data of all those endpoints would be there in one single call, and you just give the client what they're asking for, or give user what they're asking for. So let us say if you have GraphQL enabled, and you made this three call and you gave out the data for player, teams, and matches. Now, if the user wants player, then you will show the player data. Now, after that, if he wants team, you don't need to go back and make another transaction call to your server to give the players or matches data. You can directly show them as you already have them at the client side. That is why we said that there's an increased efficiency. So the calls and the transaction calls are really less in GraphQL. So what are different endpoints of GraphQL? So I have been doing bug bounty since long, and these are the 6 major endpoints that I've come across till now. So after my 9-to-5 job, my 5-to-9 job is again bug bounty hunting. That's kind of my nighttime job, and I love doing that. So these are the 6 common endpoints which I have come across, and the first one is like every time you'll find that. Any company that is on GraphQL, you'll always see /GraphQL a lot. So the second important thing that I wanted to discuss is that you can see on the right side of the screen there is FFUF. Now what is that? That is a fuzzer written in a Go language. And how does it help you? So you don't want to make a recursive call on a server to find out if they have a GraphQL or not. And if without like going on a website, you want to see that, okay, I have the list of common GraphQL endpoint, and I want to see if those exist or not. So this is the part of a recon structure when it comes to security, pen testing, bug bounty hunting, or black box testing. So recon phase is really, really important. So while doing recon, you use this kind of tool to fuzz out the stuff and create your own attack surface management or attack surface. So you give out your URL, the target you are hunting on, you give out the word list, and then you just start the fuzzing. So once you do that, you'll come across a scenario where the endpoints are returning 200 or 400 or 302 or whatever the status code it is. So that is how it will help you to find if there is a GraphQL endpoint or not. Now this is really important, and why this is important? Because the next 3 attacks that we are going to discuss that are all related to this type of queries. So GraphQL has majorly 3 types of queries: query, mutation, and subscription. We are talking about queries and mutation here because we don't need the third type. So query is something related or analogous to the GET request. So once you pull out a web page, you are like, okay, get home/homepage, host is google.com. That is just a query, like analogous to GET request. But when you want to change data, you want to update your profile picture, you want to update your phone number, address, you put out this kind of request like post, put, and delete in REST API. Similarly, you put mutations in GraphQL. So 2 major points: query is to get the data, and mutation is to throw the data to server that, okay, I want this updated, I want to delete this and other stuff. So now the attacker's perspective to GraphQL. From here onwards, we are discussing the different attacks, different vulnerabilities, and different security risks that one might have in the GraphQL server. Most of these attacks and everything are related to my findings that I did in bug bounty hunting, and for which I was rewarded certain amount of bounty. So time for a bad joke. Why did the GraphQL developer refuse to use REST? Any idea, guys? Any shitty idea? Like, it's anyways a bad joke, so. No, that could be a part of joke as well, though. Okay, so because they didn't want to get caught in restrictions when it came to querying the data. Thank you. I needed that, thank you. Yeah, okay, that was a bad joke. Never mind. Okay, so the introspection. A really, really, really important thing in GraphQL. Most of the developers think that introspection is a feature, and that is how I got a 4-digit bounty on one of the major, what we can say, a commercial store in Amsterdam. So introspection, the developers know it is as feature that, okay, it will help developer to understand what kind of calls are available, but they forget to understand that, okay, this can even help attackers to find out that what calls are available, correct? So public facing API having introspection enabled is a bad thing. Now what is an introspection? Introspection reveals sensitive information about the nodes, the calls, the variables which are available in the underlying data model. So in the backend, without hitting or clicking every button on a web page, I can easily know that what kind of calls I can make or what kind of endpoints are available, what kind of data I can query. And we'll see how each data is connected to each other as well. So you can see here, this is just a simple, now just imagine writing this query on your own. It's illogical, like just get a REST API and remove GraphQL, right? But this is so simple, it's like how can you write this thing? But you can always copy paste, so that's fine. Okay, so this is a introspection query which will help us to get the data something like this. Now look at the bytes of data here. Do I have the image? Yeah, you can see. Do you think any human mind can process this kind of bytes? Look at the number, man. It's not possible to go to like this, all this bytes is text based. Can you imagine a text based byte? So it's not possible for you to get through each and every endpoint and determine that what thing is connected to what. So we are in technological age and we have a solution for this as well, which is known as the GraphQL Voyager. It's an amazing tool which will help you to get the introspection output like this. You can see how each data is connected to each other, how from what table you can jump to what table. So you just need to copy paste your introspection output and then it will do its magic, correct? So this is much more simpler to read that, okay, in the root query, I have this call enables. From this specific call, I can jump to this call and make this call. So same thing happened with the company I was targeting. Okay, I'll take the company name as well because it's been more than 90 days. The company was jumbo.com. They are using GraphQL. They are the supermarket store in Netherlands. So what they did was one of their public-facing API was revealing the introspection query. Now, problem was that the whole introspection or each query out there was unauthenticated. So if I want to purchase the bread, I could throw up a mutation query, lower down the bread price, purchase the bread, then increase the bread price, so no one really knows that what happened. I could literally do 0 point something and buy out the bread and just change the price. Okay, so giving out, and those calls are not available to normal user, correct? You don't want any end user to know that what is a call to be made to change the prices or get the user address which is connected to every email address. Just imagine you guys have an email address in Walmart, Target, and in that you have the addresses, your home addresses. So if I call specific email address, I could get all of your home address as well, correct? So those calls were not authenticated. I could get whatever data I want. So they had a low security budget, so they didn't award me much, which makes sense that why they were having low security budget. But anyways, so that was the first finding I ever made on GraphQL, the introspection query. And it's not a feature. It's a feature if it is not on public API and they do not allow unauthenticated calls. If that's the case, then that is a feature. Otherwise, it's a well-known security risk. So I worked with Cequence. I've been doing intern from last 8 months. And I have created something which can easily help you out to find the introspection queries and if your server is vulnerable to introspection or not. So you just give out the domain to us or top level domain to us and we'll let you know if your server is vulnerable to introspection query or not. This was just the demo. Okay, so next attack that I wanted to discuss is the batching attack, or what is a batching. So take a batch as a cube-like thing or a chunk-like thing where you can send multiple requests in a server within one request. This sounds confusing, I know, but let me explain you clearly. So first of all, the exploit for batching is DOS attack and authentication bypass. Now DOS is really easy to make because of the batching and its functionality. But the major thing I want to talk about, or my finding, is the authentication bypass. First, let us see what is batching. You can see here that there are 2 queries inside a single query. So this is an array-based batching, where inside an array or a array query, I have multiple queries which are comma separated. So, and for each query out there on the response side, I have an error, which suggests that, okay, GraphQL server is taking every query and responding to every query, correct? So if I have 2 queries out there and 2 errors, that means that, okay, batching is there and I can do DOS attack. So writing out multiple queries, just look at the execution time here. It's 538 milliseconds with just 2 queries. Now, what if I write 1,000 queries and there is no limit of queries I can write? Then look at the execution time. Now, this might be the case. You are thinking like that, okay, then we'll just open up a new tab and write a new query and get the output. That's not the case. The real reason behind this is that you send this kind of request multiple times, open up a new window or a new web page or a new request and try to get out the data or send in the data. You will see that there is a significant delay in each and every request because your previous attack has consumed all the resources inside the server. So that is how you can, and if you do this multiple times, do this attack multiple times, at the end of the day, you will receive 502 or 5xx code, which will say that, okay, there is a server-side error or client-side error going on. This is an important thing, authentication bypass with the help of batching. So one of an Indian education company, they did a smart move by removing the password from two-factor authentication. So what they did was just an email field. If your email is valid, we'll send you out an OTP, enter that OTP, and then you're good to go. I'm not sure why they did that, because OTP was meant to confirm that, okay, you are the correct identity, even though if your password is leaked. But they just removed the OTP, password, and just kept the OTP, which doesn't make any sense to me. But they did, so never mind. We are there to exploit it anyways. So there is this tool known as hunter.io. Everyone here is aware about hunter.io. If not, let me tell you. Hunter.io is a service which will allow you to get email addresses of most of the guys of a company. So you just have to write the company name, and all publicly available resources would find, like CEO, CTO, CFO, whoever email address you want, you can directly get it from hunter.io. So first I did this on my own account because I wanted to try if this bypass authentication really works or not. So once I was able to do that, I got to hunter.io and found out the email address of one of the tutor. Now that tutor was taking a lecture on a data science out there, recording videos. Now once I was able to do authentication bypass of his account, I could easily remove any student, edit any course, delete any course, or remove him directly just by changing his data with my data. Correct. So how did this thing happen? As I told you before, mutation query are used to just send in the data just like the post request. So if you know that when you write the OTP, a server or a web page makes a post request call to the server sending out your OTP, and if that matches, then you are logged into account. So here we played with the mutation queries, chaining it with the batching request. So as you know, in batching, we send multiple queries inside a single query. That is a simple rule of batching. So we use that. What really happened was, you can see the first part of the picture is the mutation query, and the last part of the picture is the variables. Variables are the OTPs which you write on the web page. So here we have 3 inputs, but technically you could have n number of inputs. So if it is a 4-digit OTP, just have 0000 to 9999. But we can always skip 0001, 0002, 0003, because never in my life I have received 000x OTP for I don't know what reason. That's a good point to think anyways. So yeah, so we could write any number of OTP here. If any one of the OTP is correct, you would get the correct response. So that happened in that case as well. Multiple OTPs, they didn't have a rate limit out there. Even we don't need even rate limit here. So batching is even bypassed to rate limit, because here you are not sending multiple requests, correct? You might have known, you might have come across this word rate limit, where if you send X amount of requests in Y amount of time, then your request would be blocked. But in this case, we don't even need that, correct? Because it's only one request having multiple queries, having multiple OTPs, and if any one of them is correct, then boom, it's gone. So technically, we could exploit this more, because every CEO would have an account on his web page. So I could take a CEO account as well. But there is this known as responsible disclosure, and that is what we did. We did a responsible disclosure, solved this issue. It's pretty new, so I can't take the company name, but yeah, this really works. So authentication bypass with the help of batching, where you don't even need the rate limit. So if you are considering that, okay, there are rate limit in place. No one can do OTP brute forcing. But if you have GraphQL, no one really needs OTP brute forcing. You just need the batching vulnerability. The same way, we have something known as testing for directive overloading. Now, what are the directives? Directives are a good feature in GraphQL, but as a bug hunter, as a security researcher, our job is to test every feature and make that a bug. The opposite what QA does, making a bug to a feature, but we do the opposite, making a feature to a bug. So what are the directives? So there are two basic directives which will help you to understand what are the directives: skip and include. So just like in the for loop, we have if I is equal to 0, I is less than 10, I plus plus, like everyone knows this shit. So if I is less than 0, then execute this, 1, execute this, 2, execute this. Same way in directives, skip if. So if name is equal to Parth, then just don't do this execution flow. And include is the opposite of skip, that if name is equal to Parth, then include these flows. The feature of GraphQL query is that you can have n number of directives in your server, and those can be customized. So it's not like there has to be a @skip or @include. You can have @elephant, @dog, @whatever you want. Okay, and the best part of this attack is that you don't have to know the directives available in your server. I don't really care if @skip is there, @elephant is there, or @dog is there. No one really cares. You are here to exploit the server because I can call directive and any directive I want. So if I write or call, okay, so directives are precedented by letter @. So wherever in the call you see @, and after that whatever is written, that is a directive, like @skip, @include. So this type of error goes along a line of batching as well, where I call multiple directives @AA thrice, and if I get 3 errors in the response code, then that is like a vulnerability. Okay, so you can see here, it's not a vulnerability though, it's a risk, and we'll be discussing what is the vulnerability here. So you can see here I have written 5 @AA, and when you see the response, you have multiple errors, confirms that there could be a directive overloading issue. It's not sure that there is an issue, but there could be a directive overloading issue. Now in this case, when we see, this is again a research purpose, but yeah, you can see the execution time is 412 milliseconds, but when we do the attack transaction, the attack time increases exponentially with every directive call. Okay, so why this doesn't work every time? Okay, yeah. So coming on directives, multiple errors confirm that server is vulnerable to directive overloading. It's not a feature if you are able to call X number of directives in a request. So what could be the possible mitigations of all these attacks? Does anyone have any idea? Like, you can't do rate limit because that's out of question. What else you can do to block this kind of attacks in your GraphQL server? Anyone? Limit the number of? Yes, that's a good point, and that's what we are going to discuss. Depth limiting, that's the exact thing what you told. Depth limiting of incoming GraphQL queries. So many times you think that GraphQL is efficient. It is efficient. Like we just discussed why it is efficient, because you don't have to go back and forth every time to call out the data. But the depth limiting is an important thing when you are putting up your GraphQL server, because you don't want attackers to call X number of queries, right? Or calling each and every node. Now there is this thing known as cyclic queries, where what happens is from table A, you can go to table B, from table B you can go to table C, and from table C you can again come to table A. Now imagine that you keep calling this kind of stuff, and it will go to cyclic query, correct? So cyclic query is again a type of a DOS attack, which is included in batching, of course. But this kind of stuff you can easily know because of the Voyager magic, where you can easily identify, okay, from where I can jump to where to create the cyclic DOS attack scenario. So depth limiting is really important. Enforcing rate limit for incoming requests per API client. Rate limit, you should have rate limit. Why? I'll tell you. I just said that rate limit is not important, but when you have the first mitigation in place, that is depth limiting the query, then you should have rate limit, because it might happen that, okay, you have that limited till 5, so no more than 5 queries a user can call. But what if I call those 5 query 100 times? Then it would be the same scenario. So for that reason, you should have rate limiting in place. Disable introspection query in public APIs. If you don't want to disable introspection for developers' use, then just put everything behind authentication and not the easy authentication, not admin, because this thing happened with Best Buy as well. Best Buy uses GraphQL. They had authentication, but not proper authentication, which is now, of course, solved. That's why I said. But yeah, so it's really, really important to have everything behind the proper authentication, or just disable in the public API call. You don't need anyways introspection in public API calls. So, and use of whitelist characters is not should be allowed. Only whitelist characters should be allowed to prevent all the kind of injection attacks like SQL, XSS, and other stuff. Yep. So I guess that's everything from my side. If you guys have any questions, please let me know. Yes, ma'am.
Well, actually, let's pause for just 1 second before we take questions, because we have to get you a microphone so it ends up on the recording. But before we do that, how many people learned something in the session about GraphQL? All right, like pretty much the whole room. That's so great. So let's give Parth a hand for his very first Dash talk.
Thank you.
All right, so the way this is going to work, and we have time for just a few questions, so you're going to raise your hand. I'm going to sprint to you with this lovely foam microphone, and then you will speak into the front of this, which we will bring up at some point. And there it goes. And your question will be on the recording.
Thanks. So how did you get that directive not usable in this location error? What was the GraphQL query you sent to get that?
Okay, let me get back to the slide.
Thank you.
Okay, this one, correct? So can you just repeat your question once again, if possible?
I just didn't see what the GraphQL query was that you sent in order to get that error message about directive not being allowed.
Okay, got it. So you just send in the query, you just send the directives that you want to try, or you don't really need to know what the directive it is. But if you see the error closely, it is that directive A can only be used one at the location. That means that there might be a testing directive AA in their GraphQL query or GraphQL server somewhere, which I don't know what data it takes or what is the condition of that directive. But what we are concerned is with the multiple errors that we are getting. Okay, that even though it can be used only once, GraphQL server is still returning the output for each and every directive that I have written. So it is still processing all the directives. But I can only use it once, because that could be the part of the, what we can say, the condition to use the directive.
So you just pass any random thing? You just pass an @elephant there?
Yeah.
Okay.
You can pass anything you want.
One here.
Yep, yes, sir.
Great talk. Thank you very much.
Thank you
Learned a
so
lot. The question is, if you were to predict the future, do you see GraphQL slowly replacing REST APIs and people will less and less use REST and more GraphQL, or do you think they'll both become equally popular?
Good question. So I think that GraphQL would be broadly used in all the companies, because the extensive advantage that one has when they use GraphQL, the efficiency they don't have to go back and forth and keep calling all the data from the server. So I guess I have seen many companies moving to GraphQL. So my usual take is that I keep all record of all the companies that are having hunting on and do bug bounty hunting, and revisit them after a certain period of time just to see what has changed, what architecture has changed, are there any new functionality that we can exploit or not. And in that case, I have found that, okay, 3 to 4 companies have now moved to GraphQL and removed the REST API thing. So I think, yes, they are moving to GraphQL.
All right, well, we're right at time, so thank you, everybody, for coming out.
Thank you so much for joining, guys. Thank you so much.